Confused about CSR, SSR, SSG, ISR, or even edge rendering? Here's the fastest and most complete 2025 breakdown of modern web rendering in under 3 minutes. Here the browser does all the work. Server sends just an HTML shell plus JavaScript. The browser runs the JavaScript to build the UI. This is used by React CRA, Angular, and Vue SPAs. Pros include highly interactive dashboards, fast navigation after the first load, and it works on static hosting. Cons are poor SEO and empty HTML on first load and heavy JavaScript bundles. It's best for internal dashboards and admin panels. With server-side rendering, HTML is generated on the server per request. The browser requests, the server fetches data, sends fully rendered HTML, and the browser then hydrates with JavaScript. This is used by Next.js, Nuxt, Remix, and MVC frameworks like Laravel or Django. Pros include great SEO, fast first load, and it's ideal for dynamic content. Cons are high server load, slower navigation if caching isn't used, and it's costlier to scale. It's best for e-commerce, personalized pages, and user-specific dashboards.
SSG, or static site generation, means pages are pre-rendered at build time and served as static files via a CDN. This is used by Next.js, Gatsby, Hugo, and Jekyll.
Pros are super fast, SEO-friendly, and cheap to scale. The main con is that content becomes stale until the next build. It's best for blogs, marketing sites, and documentation.
ISR, or Incremental Static Regeneration, is a hybrid of SSG and SSR. Pre-built pages regenerate incrementally in the background after a time interval. This is used by Next.js.
Pros are fast as SSG, fresh as SSR, and no full rebuilds. The con is a short stale window before regeneration. It's best for news sites, large catalogs, and semi-dynamic content.
ESR, or edge-side rendering, means HTML is rendered at the CDN edge closest to the user.
A request triggers an edge function to render, and the browser receives low-latency HTML. This is used by Versal Edge functions, Cloudflare workers, and Netlify Edge. Pros are ultra-fast global performance, personalization at scale, and low server load. Cons include limited runtime and tricky debugging. It's best for global apps, A/B tests, and personalized content. Streaming SSR, with React server components and Suspense, means the server streams HTML in chunks instead of waiting for the full page.
The browser paints parts instantly. This is used by Next.js and Remix.
Pros are extremely fast TTFB, and it's perfect for heavy or slow data pages. Cons are that it needs modern infrastructure and has more complex error handling. It's best for real-time dashboards and data-heavy pages. Progressive hydration, or islands architecture, means only parts of the page, called islands, get hydrated with JavaScript.
Everything else stays static. This is used by Astro, Quick, and Next.js.
Pros are minimal JavaScript, superb performance, and it's ideal for slow devices. The con is a more complex mental model. It's best for news portals, marketing sites, and content-heavy pages. Now we will do a quick review. CSR, browser renders, poor SEO, slow first load, great interactivity. SSR, server renders per request, excellent SEO, higher server cost. SSG, build time HTML, fastest loads, not good for frequent updates. ISR, SSG plus regeneration, fast and fresh. ESR, render at edge, ultra-low latency, global performance. Streaming SSR, stream chunks, very fast perceived load.
Progressive hydration/islands architecture, hydrate only needed parts, minimal JavaScript, maximum performance.
For dashboards and SPAs, consider CSR. Real-time and personalized apps benefit from SSR or streaming SSR. Blogs and marketing sites are best with SSG. E-commerce and news sites can leverage ISR. Global audiences will find ESR most effective. For content-heavy, low JavaScript needs, islands or progressive hydration are ideal. If you found this useful, subscribe Evensiva Digital Services for the smartest breakdowns in web development, front-end architecture, and modern tech.